Hi guys, this is Ms. Miner, and this is 8B. We're talking about exponents, and today we're going to figure out what happens when I have some parentheses this time. Okay, so what happens when I take a monomial to another power? And really what we're doing here is we're putting parentheses into the mix. So that's we're going to have to think about our order of operations now. Remember, the first thing we do is take care of any parentheses first. So we can simplify inside the parentheses, and then we can apply the exponent if we need to. Okay. And then also, how does that work when I have an exponent outside of the parentheses? So let's just think about this really quick. When we had parentheses before, right, it was something kind of like this. And so what did we do when we had parentheses before? Well, we took our 2 and we multiplied everything inside the parentheses by 2. And we simplified it by using what we call the distributive property, where we distributed that 2 inside the parentheses. So kind of same sort of situation happening with parentheses here, but it works just a tiny bit different when I have an exponent. So let's kind of take a look at how it works when we do that. Let's not start right here with the rules. Let's kind of go back to this page here, and let's just kind of think about what is happening when I have a parenthesis, or when I have an exponent to start with, right? Like if I have x to the third power, what is happening there? Well, if we remember from yesterday when we were talking about exponents, it is x times x times x, right? And remember when I had a 2 in front of the exponent, the 2 was not affected by the exponent. The 2 was my coefficient, and so this was just 2 times x times x times x. The exponent only affects its base that is right in front of it. So we kind of talked about that. And then today what we're going to find is, well, let's kind of start there. Today we're going to add in some parentheses. So here above we had 2 times x to the third, and it came out like this. If I put parentheses in though, now let's do 2x to the third. Well, what the parentheses are telling me when I have this exponent outside of parentheses is now this whole thing, anything that's inside the parentheses, anything inside the parentheses is now its base. So instead of having something like this, like we had before, now it's telling me I have 2x times 2x times 2x. And so that would be the expanded form. Whatever is inside the parentheses is now getting multiplied the 3 times. And if we were to, let's just say, use the rules of multiplying exponents to simplify something like this, then this would be 2 to the third power x to the third power, because I would be adding up all of these exponents together. Or if this helps, what I'm doing is multiplying 2 times 2 times 2, so I would get 8. But let's look at it in terms of exponents here, right? 2 to the third power x to the third power. Look at what I started with here. Look at what I ended up with after I simplified this expansion. Let's see if we can come up with a shortcut method for what's happening here. Hopefully you noticed kind of what's happening here is this exponent is getting distributed to each thing inside the parentheses. And that is exactly what happens. It's kind of like when we had distributive property before and we distributed the coefficient inside the parentheses. If I have an exponent, if I'm raising the stuff inside the parentheses to an exponent, then everything inside the parentheses gets an exponent. So now let's do one that's just a tiny bit different. What if I had something that already had an exponent on it, like x squared, right? Raised to the third. Let's do this, okay? Well, what that is expanded is x squared times x squared times x squared, right? And the rules of multiplication, if I simplify this expansion right here, say take that exponent and add up how many you have, right? The rules of multiplying exponents say add the exponent. So I end up with 2 plus 2 plus 2, which would give me x to the 6th. Now take a look here. What do you notice about what we ended up with and what we started with, right? Well, if I have an exponent and I'm raising it to the exponent, the rule is I can multiply the exponents together. 2 times 3 would give me the correct exponent that I needed at the end as a result. And so whenever I'm raising a power to another power, what's happening is these two exponents are getting multiplied together to give me my result. So let's just kind of review a tiny bit. If I'm multiplying exponents together, right, the rule is add the exponents. If I'm just multiplying monomials together, the rule is add the exponents. But if I am raising an exponent, I have parentheses now involved, right? Then the rule is multiply the exponents. And so there is kind of the difference between those two rules. One of them I have parentheses, one of them I don't. And if I think about this in terms of expansion, right? This is just saying I have x times x. And this is saying I have times that by 3 more x's. This one down here with the parentheses is saying take x squared and multiply that 3 times. And so there's the difference between what is happening with just plain multiplication and what is happening when I am turning that x squared into its own base by raising it to another power. So hopefully you can see the difference between what is happening there. Okay, so let's take a look at just some instructions for how to do this. And I'm going to add a page in here, and then I'm going to split page it just so that I have a little workspace. And so this is kind of my checklist for, what I want to do, and you can kind of go through and make your own checklist. What I like to do first whenever I have a problem like this is I like to go in and insert any invisible ones, and I'll tell you why. Let's just for a minute take a look at just the very first part of this problem. Let's just take a look at that problem there. 2x to the 6th raised to the 5th. Now remember, what I'm really doing is I'm taking everything inside of this parentheses and timesing it by itself 5 times, right? 2x to the 6th, 2x to the 6th, 2x to the 6th, 2x to the 6th, 2x to the 6th. Okay, so that's what's happening there. But what I have a lot of times, one of the most common errors when students are raising a power to the power is that they forget that this 2 is also being affected by that exponent of 5. And so what I end up with is students telling me this is 2x to the 30th. And they get this part, multiply there, but they also forget to multiply here. So what I usually have you guys do to start out with, or a good tip so that you don't make that error, is to go in, and the first thing you should do is insert any invisible 1 exponents in. And by that I mean, if anything doesn't have an exponent inside the parentheses, I give it the exponent of 1 so that I remember to multiply that 5 exponent by each one of those things inside the parentheses. It helps to kind of train my brain to remember to give an exponent to everything inside the parentheses. And so then what I end up with is 2 to the 5th power x to the 30th power. And then I can take my calculator and calculate this number. But because there's more things going on in this problem over here, we kind of want to maybe just hold off on calculating out what this is for just a minute, and we'll see why, okay? Because now we're going to take this and we're going to do a lot more stuff with it, right? So for now, let's just go back to our original problem and let's see how we would solve this. Okay. So lots of things happening here. We're going to have to use multiple rules in order to solve this completely. But order of operation says I always start with parentheses. So that's where we're going to start first. The first thing I'm going to do is I'm going to go in and I'm going to insert any invisible 1 exponents. That means everything in this problem is going to get an exponent. Every kind of individual number or letter, if it doesn't have an exponent, I'm going to give it an exponent. That's what I'm going to do first. Whether it's a letter or whether it's a number, everything gets an exponent. Then that's step 1. Step 2, the next thing that Ms. Miner kind of does is I just simplify inside the parentheses. If I need to combine any like terms inside here or kind of simplify anything inside the parentheses, I do that first. But if I can't, like right now, I can't really, then I go ahead and multiply the exponent by the outside exponent. So whatever's out here, I kind of distribute it to the inside. And I'm going to do that with this one over here as well. I'm going to multiply both of those exponents by 7. And then this one down on the denominator, this guy down here, he's just going to stay the same. I'm not going to do anything with him just yet because he doesn't have parentheses. Okay, so I'm just going to take care of my parentheses now, and I'm going to end up with 2 to the 5th, x to the 30th, times 2 to the 7th, x to the 21. And that's all going to be over 2 to the 1st, x to the 7th. Okay, then step 2 says, after I simplify in the parentheses, I need to use my multiplication and division steps from above. So now this is just kind of a regular problem that I can solve using my multiplication or division steps. What I need to remember is that now this 2 to the 5th power is acting like a base. And so I'm going to apply the rules of multiplication to those 2's as well. I'm going to treat them like they're a letter instead of a number. And so in this top half, I'm just going to simplify the top half first. Right here, I'm just going to simplify that a little bit using my rules of multiplication. And so I'm going to take 2 to the 5 plus 7, and I'm going to take x to the 3 plus 21 and simplify that. And that's going to give me 2 to the 12th, x to the 24th. And now I'm going to add back in my denominator from above, 2 to the 1st, x to the 7th. And then the last thing that I'm going to do is I'm going to go ahead and use my rules of division to divide these two parts. So remember, my rules of division say I find a matching base and then I subtract the exponents. Wherever there's more exponents, that's where my base is going to end up. So I did 2 in the top because there were more exponents in the top, and then I took 12 minus 1. That gave me the 11. And then I'm going to do the same thing up here. There's more exponents in the top, and so I'm going to take 24 and minus the 7 from the bottom and get let me do this really quick. 24 minus 7 is going to give me the 17. Okay. And then that's all going to be over 1 because I've kind of used up everything in the bottom half of this equation. They've all kind of canceled out, and all of my remainder exponents ended up in the numerator. So I can simplify this one more time, and I can actually go ahead now and calculate out what 2 to the 11th power is. I'm going to use my calculator to do it. 2 raised to the 11th power is 2048. X to the 17th. And there's my final answer. Remember the 1 in the denominator. Anything divided by 1 is just that number. And so dividing by 1 is not going to change my result. My result is just going to be 2048 x to the 17th. And there's my final answer. Okay, let's do the next one. Okay, just set up some more blank workspace. Let's do this next one real quick. Let's see what's happening there. So the first thing that I want to do, there's a couple of different ways that I can do this. The first thing I always want to do is take a look at what's inside the parentheses and insert any invisible 1 exponents in. So I'm going to give that 2 an invisible 1 exponent so that everything has an exponent. That's what I like to do. Now there's a couple of ways that I can do this because my next step says simplify inside the parentheses. So what I can do is I can actually go ahead and simplify all of this stuff inside the parentheses first. I can use my multiplication and division steps and simplify what's going on inside the parentheses first. So let's try it that way. First thing I want to do is I want to use my rules of multiplication to simplify the denominator and then add up the exponents of the b's. So I've gotten that far, and then I want to do that again, but this time I want to use my rules of division to go ahead and divide these two things. And so I'm going to leave the 2 where it is, and then the b is going to end up in the denominator because that's where it's bigger, and then I'm going to do 7 minus 2, and I'm going to end up with b to the 5th. And remember, this was 2 to the 1st. I can put that exponent back in there. It hasn't changed at all. Then once I get done, everything inside the parentheses is going to get an exponent of 7. I'm going to multiply an exponent of 7. Remember, that's 1 has an exponent of 1. This has an exponent. This has an exponent. And so my final answer is going to be 1 to the 7th power over 2 to the 7th power b to the 35th power. And I could calculate out what 2 to the 7th is. 1 to the 7th power is just going to be 1. And then 2 to the 7th power is going to be 128 b to the 35th. And there's my final answer. So then I just go through with my calculator and calculate out my numbers that have exponents on them. That's one way that I can do that. And that's perfectly acceptable. If I like simplifying inside the parentheses first and applying the exponent later, I can. Or let's try it another way. Okay, got to get some more blank workspace here. Let's try the same problem another way. Remember, again, everything inside the parentheses is now the base. This whole thing inside the parentheses is getting multiplied by itself 7 times. That's what the parentheses are saying, right? And so the way that Ms. Miner kind of likes better for a situation like this is just taking, putting my invisible 1 exponents in, and then going ahead and distributing my exponent first. Ms. Miner usually likes this way better, but it's up to you which way you like better. So I'm showing you both ways. So I like to distribute my exponent first, and then I can get rid of my parentheses. And so I end up with b to the 14th on top, b to the 21 on bottom, times 2 to the 7th, b to the 28th. Then I'm going to go through and use my rules of multiplication and division to simplify this. And so on the bottom, I'm going to get, on the top, I'm going to still have b to the 14th. On the bottom, I'm going to have b to the 21 plus 28 and times 2 to the 7th, which is going to be b to the 14th on top, 2 to the 7th, b to the 49th. And then I use my rules of division to take care of this guy and that guy. So there is going to be more exponents in the bottom for b. And then I'll take 49 and minus all 14 of those. So they're going to cancel out. That's why I'm going to put a 1 in the top. And this is going to remain a fraction. Remember, if everything is down here in the denominator, then I need to put a placeholder in the top if everything cancels out, if everything is subtracted off of the top. And so I'm going to put that placeholder 1 in there to keep this a fraction. I've got to have a numerator and I've got to have a denominator. So when everything cancels out of the top, I'm going to put that 1 back in there. Everything kind of went to 1. That's what we are doing when we cancel something out. And so I'm going to end up with 2 to the 7th in the bottom, b to the 49 minus 14, and that's going to give me the b to the 35. Oops, 35 there. Okay, so then I can calculate out 2 to the 7th power and get 1 over 128 b to the 35th. So a couple of different methods for solving that. You will notice we got the same answer each time. And so it doesn't matter which way I decide I want to solve those problems. Let's have a little practice. So what I'd like you to do, well, I'm sorry, I forgot about negative numbers. We got to talk about negative numbers and how negative numbers are affected by an exponent. This is important because we're going to introduce some negative coefficients today. Now we're talking about negative numbers or negative coefficients today. We are not talking about negative exponents yet, but we will. But if I have a negative number, let's say I have like a negative 2 to the 6th power. Well, I have to kind of remember something because we're talking about order of operations today. We've had some parentheses. And so we're going to come back to our order of operations to kind of help explain what's happening. Remember, exponents are second in my order of operations. I don't get to addition or subtraction being applied until the 4th step in my order of operations. Parentheses, exponents, multiply, divide, add, subtract. And so here's the thing about exponents. An exponent is applied first. Well, parentheses are applied first, but then exponents, right, are second. Let's do that in my order of operations. And add and subtract isn't until the 4th step. So exponents get applied first when I have a negative number. And so this is telling me, take the negative of 2 times 2 times 2 times 2 times 2 times 2. And what I'm going to end up getting is negative 64, because I'm going to multiply all of this together first before I take the negative of it, because negatives, remember, are also the same as subtraction. And subtraction doesn't get applied until after multiplying and exponents both. And so that's negative is not actually getting affected by that exponent. The negative is after the fact. Remember, the other thing that we talked about with exponents is they only apply to the base that's immediately in front of it. And so even though this negative is that 2's best friend in the whole world, and they're stuck like glue, they love each other so much, the exponent is only being applied to the 2, not the negative. However, and this is where it gets to be a little bit tricky, right? I'm going to use a 1 as my example here. We just talked about how parentheses are affecting, oh, sorry, I've got to get my arrow here. What if I now put parentheses around that negative? Well, now the negative is included in the base. The negative is included in the base this time. And so now what I have is a -1 times a -1 times a -1 times a -1 times a -1. 1, 2, 3, 4, 5, times a -1. And every single time I end up with 2 negatives in a problem, and you may remember this from earlier in your, like from 6th or 7th grade talking about negatives. When I have an even number of negatives, they cancel each other out. They turn positive, right? And so here's 2 more negatives that are going to cancel each other out. And then here's 2 more negatives that are going to cancel each other out. So when I put parentheses around the negative, I end up with a positive answer. So parentheses are kind of including the negative now, and I have to take care of that negative and apply it as if it were getting an exponent of its own, right? There's 6 negatives there now, which is going to make my result be positive. What if I have an odd number of negatives, right? So what if I have an odd number of negatives? This is telling me take -1 times -1 times -1 times -1 times -1. And when I have an odd number, these 2 are going to cancel, these 2 are going to cancel, but I'm going to be left with a negative left over. And so my result here is going to stay negative, just as if there weren't even any parentheses there. If I have this is 1 to the 7th power, and it's still negative. So really the only time that I'm going to end up with a positive is if I have an even number of exponents, an even numbered exponent, and parentheses. So if I have negative numbers in there, I have to be careful about that. I have to be checking for that, and that's something I want to look for. Okay, so let's try this out with some negative numbers and some parentheses in our problem and see how we're getting affected here. And I'm going to put back my workspace here. We're going to try to do some of these things. Okay, so what I've done up here is I put all of our steps. Here's our multiply steps. Here's our divide steps. Oops, don't go anywhere. Oh, my pen's not loving me today. Okay, and then here's our power rule. So our parentheses rule, right? Okay, so we're going to start with our order of operations. And remember, our order of operations first starts with parentheses, then exponents, then multiply or divide, and then addition or subtraction. Okay, those are sort of our order of operations. Let's take a look at just this first problem, and I'm going to start with this up here because parentheses. So the first thing I'm going to simplify is y to the 4th raised to the 8th power. And so I'm just going to distribute that 8th power inside. And so the top part of my equation now is y to the 32nd. And that's all going to be over 2x squared y to the 5th times negative 2x squared. Okay. Now my question is, because I have this negative number, is this 2 affecting this negative out here? Hopefully your answer was no. That 2 is only affecting the x because there's no parentheses. So I don't have to worry about that. This is just a plain old negative 2, and we're going to treat it just like a plain old negative 2 and multiply it by our 2 on this side to get a negative 4. Our rules of multiplying say multiply any numbers together. And I'm just going to simplify this denominator by multiplying. So the next thing I want to do is I want to find some matching bases. Here's an x, and add those exponents together. 2 plus 2 is 4. And then I'm just going to leave the y to the 5th because it doesn't have any matching y's on the bottom. So now my problem looks like this. Y to the 32 over negative 4, x to the 4th, y to the 5th. And so the last thing I can do then is use my division rules. I want to highlight any numbers that I have. Here's a number. And simplify my fraction. Well, negative 4 can't be simplified, and there's no coefficient up top. And so I'm just going to leave the negative 4 in the bottom where it is. Then I'm going to match up any variables. Y and y match up. So I'm going to end up with y to the 32 minus 5. And it's going to end up in the numerator because there's more exponents in the numerator to start with. And so 32 minus 5 is 27. And then I have to decide what to do with x to the 4th. Well, I'm not going to do anything with it. There's no other x's in this problem, so it's not getting affected by anything else. And so my answer is going to be y to the 27th over negative 4 x to the 4th. Okay, what I'd like you to do is pause the video, try this lower problem on your own. See if you can do it. Here's a tip. Look at, there's a negative inside the parentheses. And so I have to decide, is my result going to be positive or negative? If I have an odd numbered exponent out here, how many negatives am I going to end up with? So ask yourself that question first, and then pause the video, see if you can come up with a solution, and then check your work. Okay, hopefully you paused the video. And so what we're going to do now is I'm going to go through this problem with you, and you can check and see how you did on your own. Okay, the first thing we want to do is anything inside the parentheses. And so that's where I'm going to start. Remember, everything inside the parentheses is getting affected by this exponent that's being raised outside here. And so I'm going to start by going through and giving everything an exponent so that I don't forget to give an exponent to everything. And even this negative is being affected by that exponent of 5. I have 5 negatives in this problem. So the top half of my equation over here is going to be negative. It's going to come out negative because of those 5 negatives that are inside the parentheses. Then I'm going to go ahead and multiply each of these by 5 in order to distribute the exponent. I'm going to end up with 2 to the 5th power, h to the 25th power, j to the 20th power, k to the 20th power. And that's all going to be over negative h squared, j to the 5th, k to the 5th, times negative 2, h to the 5th, j to the 4th. Okay, sweet. Now I don't have any more parentheses. I can kind of, let's see, I just want to scroll up a tiny bit. I can kind of start to just go ahead and use my multiplication and division steps from above in order to solve this problem. Okay, this is how I do it. Wherever there's more going on, that's where I'm going to start simplifying. So down here in the bottom, I got a lot more going on. I'm going to start by simplifying the bottom half of this equation. I'm just going to leave the top half just how it is. 2 to the 5th, h to the 25th, j to the 20th, k to the 20th. And in the bottom, I'm going to go ahead and start right here. I have one negative, and it's being multiplied by a negative. That means I'm going to come out with a positive. And then this is going to be a positive 2. And then I'm going to combine all of my like bases. So here's an h, here's an h. H to the 2 plus 5 is going to be h to the 7th. And then here's a j, here's a j. J to the 5 plus 4 is 9. And then finally I have a k to the 5th power, and it's not going to change because there's no other k's in the bottom being multiplied. Now I've simplified the bottom. I can go ahead and divide the numerator and denominator. So now I'm using my division rules to do that. The first thing that I need to do is take care of my numbers, my plain numbers. So here they are. Negative 2 to the 5th and then 2 to the 1st. I didn't have an exponent there, but remember, if I need an exponent there, I can always put an exponent in there. All right, so this one, this 2 to the 5th, that negative is not being affected by that 5. And really, well, yeah, and so it's a negative. This one is a positive, right? And so if I have a negative and I'm dividing it by a positive, then my result is always going to end up negative. Okay, so I've already taken care of my exponent or my signs. I can go ahead and do my 2 bases. 2 to the 5th is more than 2 to the 1st, so my 2 is going to end up in the top. 5 minus 1 is 4. Then I have an h here. I have an h here. H to the 25th is bigger than h to the 7th. So h is going to end up in the numerator. 25 minus 7 is going to give me 18. And then j to the 20 minus 9 is going to be 11. Let me change colors here just so that we can see that. J to the 11th. And then k is going to end up in the top to the 15th. And everything canceled out of the bottom. I subtracted all of those, and all of those. And so I end up with a 1 in the bottom. And I can do one more set of simplifying. I'm going to go ahead and calculate out 2 to the 4th, which is going to give me 16. H to the 18th. J, that's supposed to be a J, not a K. J to the 11th. K to the 15th. And anything divided by 1 is just that number. And so the 1 on the bottom, because of division, it's just going to kind of go away. It's going to cancel out or be divided away. And so there's my final answer. A lot of steps are happening here. And so we kind of have to keep track of where we are, right? And that's why I've kind of written everything out. If you need to, come over and use your checklist to check off everything, right? Use your checklist to help you make sure you're not skipping for a while. Okay, that's just one more problem. We're going to hang there for just a minute. And let's just say that if you would like to practice again, here's another good practice problem you can try with. And then make sure that if you have any questions or you need clarification on anything, that you're checking in with me or Mrs. Zeider. Okay, good luck, and make sure you're emailing with any questions or concerns.